Welcome back with the second problem of the third experiment of CSE 162 Computer Programming Laboratory. In this particular problem, we are asked to find out the prime factors of an input integer. So the problem is something like this, that we need to scan an input integer from the user using our scanf function, and then we have to check that what are the prime factors of that number. So there are basically two steps of this. The first step is checking checking for the factors of that number, and then we have to check whether a factor is prime. So there are two steps of it. If I just divide the whole problem into multiple blocks, there will be several blocks. Just before going into the code, let's give an example. Let's say 10 is an input. It has total of 4 factors: 1, 2, 5 and 10. Among these 4 numbers, 1 is not a prime number, 10 is not a prime number. So 2 and 5 are prime factors of 10. Let's take another example. Let's take 50. The factors of it are 1, 2, 5, 10, 25 and 50. Among these numbers, 1 is not a prime number, 2 is prime, 5 is prime, 10 is not prime, 25 is not prime, 50 is not prime. So the answer will be 2 and 5. So this is the task we want to perform. We want to find out all the prime factors of an input integer. So we can divide the whole code into multiple blocks. The first block is scan block. In this block, we will scan an input integer from the user. After scanning the input, now we know what is the number we want to find the prime factors of. So next step would be check for the factors. Checking for factors is basically easy. Let's say a number is n. How can we know what are the factors? We can start from 2. We will not start from 1 because 1 is factor of all the numbers. You can divide any number by 1, and 1 is not also a prime number. So 1 is not a center of our interest. So we will skip 1. We will start from 2 and we will go up to n, up to that number. And in every step, we will check that whether the main number is divisible by this number. Let's say we will use a loop here, and the loop controlling variable is I. I will start from 2 and end at n. So at every iteration, we will check n mod I. It is actually dividing the number n by I and taking the remainder. If the remainder is 0, then this is a factor. This I is a factor of n. As simple as that. So if a number is factor of n, or the input integer, then we will need to check whether the factor is prime or not. Factor checking and then prime check. We already have done this prime checking problem in our second experiment. We will write a function for this. We already know what function is and how to write this. We will write a function for this, and our function will check whether the input number or the factor is prime. If it is a prime, if the output from the function is affirmative, then if it is yes, then we will write that this is a prime factor of input. As simple as that. So we already know how to check the factors. I have shown it here. Now let's talk about this function, this checking prime function. I have named it as check prime. This function takes the input number, input integer a. It will check whether the integer a is a prime or not. So it will return an integer 2. If the number is prime, the function will return 1. If the number is not prime, the function will return 0. So this is an integer type return. In the function, we will check whether we can divide this input number a by any number between 1 and a minus 1. That means is we are following the definition of a prime number. A prime number is defined as if a number is not divisible by any number other than 1 and that number itself, it will be a prime number. So we will check if the number a is divisible by any number. It will be 2. We will check whether the input number a is divisible by any number from 2 to a minus 1. If the input number is 10, we will check whether the number is divisible by any number between 2 and 9. If it is not divisible by any of these numbers, then we will conclude that this number is a prime number and we will return 1. If this is divisible by any number, then we will conclude that it is not a prime number and we will output 0. As simple as that. So this 1 and 0 will be stored in another variable. We have called it a flag variable. We have declared this variable flag, and this flag will store 1 if the number is prime, and the flag will store 0 if the number is not prime, and this flag will be ultimately returned. So that's all. Now let's go to the code and get some more insights. I have already written the code for you. This is the code. This code has all the comments with it for better understanding. I have attached this code with the lab sheet as well. So at first we are declaring our libraries, then the main function. Inside the main function we will use our check prime function. You can see the check prime function. Let's describe the check prime function first. So this is a function check prime. The definition is given here. Check prime is a function which returns it will be returns 1 if the input number is prime, otherwise it returns 0. A 1 is missing here. Okay, so int check prime, obviously it will be an int type because it return value will be either 1 and 0. It is integer number, so int. Check prime is the name of the function, and int n, it will take n integer as input. Then there is a variable called flag. We are declaring the flag as 1 by default. That means if the number is prime, we do not need to do any change to it. It will be by default 1. If the number is not prime, this flag must be changed to 0. Another variable j is declared. This j is the loop controlling variable. This loop will be used to divide the input n by every number from 2 to n minus 1. You can see for j equal to 2, j less than equal to n minus 1, and j plus plus. Here is a twist. You can reduce the computation a bit by changing this command. It is not necessary to check for every number up to n minus 1. You can reduce this computation a bit by changing this to root over of n. Checking up to root over of n is enough. I am giving it as a practice task. You can change this expression to j less than equal to root over n. You can use the power function we have done in our previous problem. You can use that, but make sure in that power function all the parameters were integer, but when you are using the root means power is 0.5, so you have to change the types to the float. Okay, so that's something you want to explore. Okay, so for every number from j equal to 2 to j equal to n minus 1, we will actually take the remainder of the division operation, and it is shown here n remainder or n mod j. It is called mod n mod j. If the remainder is 0, it can be concluded that the number is not prime, because we are finding at least one number that we can divide the original number with. So if for any j in between this range, we can divide n with j and the remainder is 0, that means that your number is not prime. So if this condition is triggered, we will go inside the if block. The flag will be changed to 0 because it is not prime, so we have to change the flag, and we have to break the loop. Once you have found one number that indicates that this number is not prime, there is no need to check further. We have actually described this break and continue in detail in our last live class, so I'm not going into detail, but whenever you have found at least the first number that is enough to verify that this number is not prime, you don't need to check any further. So you are breaking the loop and the flag is now set to 0. At last we have to return the flag. If for any j this if block is triggered, then the flag will be 0. That means it is not prime. Otherwise it will be 1 by default. That means it is a prime number. Okay, now let's get back to the main code. In the main function we have three variables, I, num and is prime. I is the loop controlling variable used for checking whether a number is factor of the main number. The main number is num, and is prime is the variable that indicates whether your factor is a prime number. So basically is prime and the flag variable are basically the same thing. So at first we are taking the input from the user. These are the inputs and just some formatting. Then checking for the factors will start here. For I equal to 2, as I said, it will start from 2. It will continue up to the number itself, and at every iteration I will be increased by 1. So now we have to check whether I is a factor of the number. So you can just do this by this operation, taking num mod I. If num mod I, or the remainder of the division operation of num by I, is equal to 0, we can conclude that this is a factor. Only if our I is a factor of num, we will check for the prime. If it is not a factor, then there is no necessity of checking whether that number is prime or not. We don't care. If the number is a factor, then we will check whether it is prime, and this checking will be done by check prime function. Check prime. We will pass this variable I to this check prime because I is our point of inspection now. We will pass this I variable to check prime, and this I will pass into this function, and ultimately the flag will be returned, and this flag will be saved to is prime. Is prime. This is prime will be either 1 or 0 depending on whether I is prime or not. If I is prime will be 1. If I is not prime, is prime will be 0, and this value will be derived from the function check prime. Now we have to check whether it is prime or not. So we will do that by checking is prime. As is prime is 1 if the input parameter I is a prime, so we will conclude that it is a prime factor, because if I is a factor, we will check whether it is prime. So I is a factor, we are checking that I is a prime, and if both the conditions are true, then we will conclude that this is a prime factor. So we will just print it. Otherwise, if the is prime is 0, that means a number is a factor but a number is not prime, then this is prime will be 0, and this if block will not be triggered because it states that the condition is prime is equal 1, so it will not be triggered. So is prime equal 1 will be triggered only when the input number is prime. So we will print it out in that case. Otherwise we will just not do anything, and we will go to the next number I will be again increased to 3. Then it will be checked whether it is a factor. If it is a factor, then it will be checked if it is a prime. Then we will conclude whether we want to print it or not. This is the whole functionality of this code. It's a very straightforward code. I have also put the comments for your better understanding. So that's it. We will come back with our last problem on recursion in our next video. Thank you.